Now we study about the resistance. Electric circuit, resistance means controls the flow of current. That is the meaning. Okay, more resistance, less current, and less resistance, more current. If it is resist, that means stops the more flow of charge means less current. If it is stopping the flow of current less means it will have the more current. Now you see R means what? Resistance. Na? Resistance is inversely proportional to the I means what? Current, ampere. So inversely proportional, not directly proportional, inversely. That means not equal. So more means less, less means more. So this is the resistance here. Okay. Factors on which a resistance depends. How the resistance changes. Okay. Okay, now you see how the resistance changes. Okay, we take the cell in the electric circuit, key is there, ammeter. And first we use the nichrome wire. Nichrome wire, this L shows the length. So the resistance depends upon the length of the conductor. Length means what? Lambana, lambi. So this it depends upon the length of the conductor. So more length, current flow, I1. Okay. So next one, length. When then current flow will be how much? Okay, now you see the difference. The resistance depends upon the length of the conductor, first point. But first one we have taken the length less. Next time we are taking the more length. Okay, L, and next time 2L. So here what is happening? Current is more here, I1. But when we take the length 2L, when we increase the length of the conductor, here the flow of current is becoming half. Okay, that means if the wire is shorter only, more current flows and less resistance. If the length increases means resistance is more, and that means the stopping the current flow, controlling the current flow will be more, and so that less electricity flow. Okay, and the next time, so that is the one half. Next, in case of 3, so length is same, but now it is thickened, now fat wire, but here we took the thin wire. Okay, so now we are taking the fat wire, short but thicker. So how the flow of current will be? And also the thicker wire, thick wire. So this place is called as a cross sectional area. Okay, so more, if in the thickness this cross sectional area is more means, so the flow of current will be more and resistance will be less. So I2 means what? So I2 is great. This is the I2, flow of current. That means if the wire is shorter and thicker means resistance will be less and flow of current will be more. Now this I2 is greater than I1. Okay, so this is the one. Understand? So that is why we use in the phone wires or TV wires, or what is that, in the computer, fridge, high current needs all these things in a heater, they have the short and thick wire. Because why short and thick wire? In short and thick wire, flow of current will be more because of the less resistance. And next one, fourth one, we are taking the copper wire. Now what is that? Different conductors flow the different types of current. That means aluminium, copper, silver, we have different types of metals are there. So the resistance depends upon the first one, length of the conductor. Second one, it depends upon the material. It is called, if the flow of current depends upon the material means whether it is a copper, steel, aluminum, like that, depends upon the material, it is called as a resistivity. Okay, so this is the one, length and same, different material, we are using the different now we use the copper wire, first we use the nichrome wire. So when we, now this current will be greater than the I1, so the resistance depends upon the length, and next one is the cross section area of the conductor, and the next one is the material. Okay, and next temperature of the conductor. All the metals will not absorb the heat very fast, or current will not flow very fast, so it depends upon the material also. Okay, so this is the one, that is why I3 is greater than I1. So in the case of, you see, length is less but current flow is more, length is more, current flow is less, resistance. Okay, so I proportional to 1 by L. Okay, so current flow is directly not equal to the length, inversely proportional to the length. I proportional to I by R, so current flow is not equal to the resistance. Okay, so more resistance, less current, more resistance. When we write like this itself, it is inversely proportional to, not equal to. Okay, case of 1 and case of 2. So like this. And the next one we see now. Okay, and R proportional to L, more resistance and less current flows. Okay, same wire we used. A means cross sectional area, the thickness na, that is the one it shows. Okay, now next one we are seeing thicker wire. So resistance is directly proportional to the L, the flow of current is directly proportional to the A, cross sectional area. Here A means, okay, this is the resistivity. This means resistive, that means the flow of current depends upon the material also, it is called as a resistivity. So R it is equal to the length, and resist is inversely proportional to the cross sectional area. Okay, so this is the one. Okay, so now you see copper wire, nichrome wire, understand? So copper wire, nichrome wire, and conductors. Resistivity means conductors means good insulators. Conductors allow to flow the electricity more. So conductors are greater than the alloys. Alloys means what? Mixture of metal or mixture of metal and non-metal called as a alloys. The conductivity of the electricity in the metals are greater than the alloys, and alloys are greater than the insulators. Insulators means plastic, they don't conduct the electricity. So resistance depends upon the material. Material means where if it is a conductor, more electricity flows. If it is alloys means very very less, because it is the mixture of the other metal or the non-metal. Conductors means pure metals only, which conducts the allow the electricity to pass. Insulator we know very well, which will not allow the electricity to pass. That is why conductors are greater than alloys, and alloys are greater than insulators. Okay, so this is the one. SI unit of resistivity is what? Ohm. So this is the ohm. Okay, so resistance, nature of the depends upon the nature of the material. That nature of the material is called as a resistivity. Okay, so low resistivity, less resistance. High resistivity, high resistance. So that is why resistance is directly equal to the resistivity. Okay, so and then low resistivity means it is the current flow, stopping the current flow also less. High resistive means flow of the current also will be high, high resistance will be high.